Okay, good morning everyone. We will start the class. The first thing I want to say is about the final project for MATLAB 2. The project will be centered on computation of fuel consumption of a car. Yeah, I want you to simulate you drive a car from your hometown to Sampurna University. You from Lombok, yeah, from Bali, right? Or you can also choose other city, yeah, to Sampurna University. Okay, so when you are driving, let's say from Bandung to Jakarta, you will drive through urban area, right? And then there will be, let's say you use the expressway, there are intersection, traffic light. Your car will be stopping at some point and then going again, stop and go, stop and go. So I want you to simulate all of those situations. Yeah. Let's see the third point in here. The car is assumed only to move in one axis, okay? Only moving in this direction, let's say. But when your car, let's say, coming into the highway, expressway, your car can go up to 100 km per hour. If it is in urban area, your car is limited to 40 km per hour. So you have to be very detailed in simulating the route. Okay. If you are facing the intersection, you have to stop. When your car is stopping, then it is only in idle condition. Yeah, the car is in idle condition. If you are choosing electric vehicle, let's say, then the energy consumption is only for the air conditioning. Yeah, this is okay. Understand? Yeah. You may ask me, so what if we use electric vehicle and then it is running the air conditioning only? What is the energy consumption? What do you think? What would be the energy consumption of air conditioning of a car? Let's say you are stopping for 3 minutes. How many energy being used? Any idea? No idea at all. Do you know a car's compressor? Air conditioning compressor for a car. Yeah, we need to rotate that, yeah, so that the air conditioning can work. Okay, and then you need also the blower, the fan, so that it can blow the air to the cabin of the car. Yeah, normally it uses 2 kilowatts of power for the air conditioning of a car, but you have to research that on your own. Okay, because different car will use different air conditioning. Let's say you choose Toyota Innova. Some students choose Honda Jazz. Let's say they use different air conditioning. Okay, so it will consume different energy when it is on the traffic light. Okay, let's say if it is 2 kilowatt, then for 3 minutes, how many joules of energy it use? Okay, you just multiply it by 180 seconds. Okay, so 2 kilowatt means 2000 joule per second. Okay, so for 3 minutes you have how many? 2000 multiplied by 180 seconds. Yeah. What if you are using internal combustion car in idle condition? How to get the fuel consumption? No idea. You driven a car before, or you are ridden a car before? Have you ride a car before? Yes. You know how internal combustion engine works? Yes, you know. Okay, internal combustion engine works. It has to burn a fuel, right? So how many fuel is burned so that your car is in idle condition? Let's say 800 RPM. How many fuel it is being burned? Yeah, that is outside of scope of the MATLAB, but you have to research this on your own. Okay, that's part of the project. Self-learning on the fuel consumption. You can use the heating value of let's say diesel or gasoline engine. Gasoline. Yeah, the heating value of the gasoline for 1 liter. How many kilojoule it's being produced? Okay, so let's say if you are in idle condition, how many watt is it needed? How many watt? How many joule per second? Then it translates into how many gasoline, how many liter of gasoline per second it is needed when it is in idle condition. Okay. Then when the car is accelerating, when the car is moving in constant velocity, it will also consume a different fuel consumption. Okay. When the car is accelerating, how do you think you can get the fuel consumption? How do you relate car acceleration to fuel consumption? What must the engine do so that the car accelerates? The engine has to give what to the wheel? Give the torque. It gives a torque to the wheel. Okay. How do you get power from torque? How to relate the power from torque and then from the car acceleration? What do you need to get? Huh? You have a torque to accelerate the car, and then what will be the power in that situation? Oh, you don't know. Are you from mechanical engineering? No idea. Your idea. Torque. Fuel. Getting the fuel consumption from the situation when the car is accelerating. How do you get it? I'm asking that one. Okay, let me tell you your idea, displacement, and then what else? Okay, she says the RPM. Okay, I'm asking. That's the keyword I'm looking for. The RPM of the engine. Yeah, because when your car is accelerating, you need a torque, right? You need the torque to rotate the driving wheel. So from that, you can get the traction. Yeah, the traction is the one that will push the car. Okay. Then the torque of the engine, you multiply with the RPM of the engine. That will be the power. Okay, the power produced by the car's engine, which is good. He says RPM. But when you relate it, when you want to relate it to the acceleration, you need the torque. Okay. And then yeah, once you get the torque of the engine, and then you know what's the RPM the engine is moving, you can readily get the power. Okay, so that's the power produced at the crankshaft of the engine, how to get the fuel you need to burn per minute or per second. Any idea? So you know the power at the crankshaft now. How to compute how many gasoline you need to burn per seconds per minute? You know the RPM already, let's say. Displacement of the engine, and then
number of cylinder,
number of cylinder,
amount of fuel produced every.
Okay, every 1 liter of fuel burn, how many kilojoule that you produce? We have a data on that. Yeah, you can search for the data for gasoline, for diesel fuel. You can get the data. Okay, so you know that from the combustion process, you can get the power. Okay, let's say for 1 liter of for gasoline, you can get 10,000 kilojoule power. So if you need 100 kilowatt of power, then you'll be able to know how many liter per second you have to burn the fuel. Okay. And any other question on this? Today we will practice on relating the torque to the acceleration, okay, of the car. So this part you need to get it on your own. This part, stopping and accelerating, yeah. So in this project, your first step is to choose the car, choose the route, and then after that you can simulate the fuel consumption. Yeah, your grade will be depending on this. Okay, how detailed your simulation is, how far also your university to the Sampurna University. Let's say you just want to simulate from Halte Perdatam to Sampurna University. That's very close, right? Definitely you will get C or less than that. Too simple. Okay, if it is too simple, no. Yes. Yes, the cars, that's the constant value. It is up to you. Follow the regulation of the, let's say on the highway, maximum speed is 100. So you can accelerate your car up to 100. After that, you keep constant speed. So how to do that? You can easily use the if condition. Okay. Yeah, the car. Yeah.
Idle.
Yeah, when you are boarding into the ship, yeah, you stop and then you are queuing, right? Yes. Individual, yes. Yeah, I forgot to say this is individual. Okay. Yeah, you say you know nothing about the car, but the idea of the project last year was that I asked the student to find nonlinear ODE on their own, a system that they never know before, and I asked them to simulate that. In here, it's easier for you because we discussed this. So don't make an excuse you don't know nothing about the car. You learn from now how the car works. Okay, come on, you are in mechanical engineering. Yes, internal combustion engine dies out. Okay, we have electric vehicle. You simulate on electric vehicle then, if you don't like the internal combustion engine. Okay. So this grade is only for the final project. Yeah, final project. The most difficult one get 100. Less difficult, less than 100. So no student will have the same, no two students will have the same grades. So I will order it from the most difficult to the least difficult one. Okay, no chance for, let's say you both get 90. No, cannot. Why? Why is that so? Yeah, last year is also like this also, yeah. But this time is easier because we study it together. What you need to submit is the MATLAB course and then the report. Okay, once you choose the car, it will give you the car's mass, right? The drag coefficient, the frontal area, engine size, the torque RPM graph is given there, right? Gear ratio in the transmission, tire size also, because tire size will affect how much traction you give for the same torque. Okay, and also the maximum speed of the car, that will be determined from the engine size also. Okay. This route, it will dictate what the total distance, variation of stop and go. If you go from, let's say, the office of BPJS, yeah, let's say, or you are on the side that will go to the Pasar Minggu. So to go to Sampurna University, you have to do what? U-turn, right? You have to take U-turn, so you have to stop first, and then take U-turn. In the U-turn, maybe your speed will be just 5 km per hour. 5 km per hour, and then after that, you are queuing for the U-turn again in the Pancoran statue. Yeah. Stop again and then going. Maybe maximum speed will be 20 or 40 km per hour in that area because of the congestion. Say that again. If it is so far, yes. Let's say you are consuming a fuel, and then after that it depletes because of the tank is empty. You have to stop, refuel. Okay. If you don't do that, then it's not that detailed, right? Okay. I want a detailed simulation. Well, that's not possible. It's illogical stopping one time. Let's say everybody is going to the Mars. What? Oh, that is possible. Resting one time is possible. Yeah, that means you are bringing at least 60 liters of gasoline. Yeah, so that is possible. From which city that you are trying to do? Surabaya to Jakarta, how many kilometers? 800 kilometers? Okay, let's say 800 kilometers. A car, what's the car? Let's say the car is Toyota Innova diesel. Let's say, yeah.
Spot on.
Is that the car? Okay. So do you know what's the fuel consumption of that car? 115. Okay. So 115, he said, yeah. I think that's a reasonable value for 115. So after you simulate it, you have to get roughly around that number, yeah. If your number is bigger, too much bigger than that, or too much lower than that, something is not right with your simulation. So we have a guessing value in that case. Okay. Yeah, after traveling from Surabaya to Sampurna, you can take the average value of the fuel consumption, right? If it is, let's say, 20 kilometer per liter, that is still good. Let's say, yeah, because we are simulating using computer, then you will not pressing the gas pedal too much in that case. Okay, if it is 100 kilometer per liter, that's not realistic. Okay, so what is the purpose of this project actually? Yeah, the purpose of this project is that when you are simulating using MATLAB, either using MATLAB or you are using other kind of software, finite element software, let's say, you have to you need to have a sense of guessing what is the value that you are that you will be getting. Sorry, you need to have a sense of the value that you'll be getting from the simulation. Okay. Because fuel consumption of the car, that is a widely known value. So we know that it is either 15 kilometer per liter, 20 kilometer per liter. After you simulate, if you don't get in that range, something is wrong with your simulation. So this is a practice for you to conquer the MATLAB. Okay, before you do the simulation, you already know the result is roughly in this ballpark, and that is the same for every kind of simulation. Yeah, so simulation is not something like you are venturing into an area you don't know, you never come there before. That's not simulation. You will get lost definitely if you do that, because you will believe anything you get from the simulation, right? Without prior knowledge, you will believe anything, then something might be not correct. So when you simulate, you need to have a comparison value. You need to compare it either with your experience or with the analytical computation. And let's say you don't believe the experience. Can you analytically compute it? No. So we know the value from the experiment. Any other question? Today we will learn about this. Yeah, this one. So from the last simulation that we have here, you assume that the traction is constant, right? Traction is constant. Now the traction will be related to the torque. So your first step is to make a engine torque graph first. Create the engine torque graph, and then you relate the traction to this torque. Then try to run the car, okay, without computing fuel consumption first. Can you do that? Yeah, I don't want to take too difficult relationship between the torque and the traction. So when you have a torque in here, okay, that's the torque, and this is the traction, let's say. This is the torque at the wheel, yeah, not at the engine. Torque at the wheel and the engine, are they the same or different? You have the engine here. The engine gives a torque. Does this torque at the engine and at the wheel, are they the same or different? Different. Why is that so? Not because of power loss. There is a power loss, yes, but that's not the main reason.
Ada conversion kit.
Yeah, conversion.
Gak tahu. Namanya juga.
Yes, there is a gearbox, of course.
Ya benar nanti. Oh.
Yeah, but the terminology. Yeah, how is it? Torque berapa?
Oh, lebih dari itu, Brad.
No.
If.
Torque, not torque 1, torque of torque 5.
No, we put the initial one dulu.
Hmm. Okay.
Velocity dari mana?
Yeah, you don't have to write down the RPM like that. No, no,
RPM
no.
doang.
Yeah, because the first RPM is dictated by the first velocity. So
Which is
you
this one.
you copy everything. You copy here to the top one, the RPM. Yeah, remove the I. On the top, remove I. Also, this one you use X, the initial condition. Number 1, yeah. Yep.
Ini berarti tidak.
No, that's correct. So the initial value of R, the initial value of RPM, depending on the initial velocity of your car. You get what I mean?
Oh, which is this one.
Yeah. Now can you run it?
Tetap salah
Still the
di
same?
sini. This one.
Oh, that one no need.
Kurang itu.
No, you remove the torque and FT, and then the traction, remove everything. Yeah, remove that. Torque also. Yeah. Okay, you run.
Jalan nanti aja lah. Oke.
My 19. X dot, they don't know the X dot. Oh, you are using underscore here with on the top. You don't use underscore. Now what is it? There is another X dot. Okay. Now what is it? Oh, left and right doesn't have the same number element. What is H? Oh, H is not 2x3. No. It's a constant. Just a constant.
So let's say
3. Okay, then you run. Now what is it? Left and right. Oh, FT.
oh FP aku sama ya. This one and this one.
FT of I. This one FT of I. Okay, now the T, what is T? Now, 3001. What is X?
Itu yang besar.
Why they have different? 50,001. This is 60,001. They have different elements.
Oh, I think
You put it here. No. Don't do that. Remove the X. Okay, you scroll down. This will be your X, right? Not the top one. So you run it now. You run. Have you clear? Go to the top. You haven't cleared. CLC and clear all. CLC. You see the okay.
berapa memang gitu ya?
Can you increase the time span?
Ini apa sih?
What do you need?
Misalnya biar fixkan RPM itu berarti if RPM is greater than RPM K plus 1 equals to K.
No, you fix the torque, don't fix the RPM.
Tapi RPM-nya yang bakal ke install. Kalau kayak gitu.
Yep. So this is
Ya itu.
that's correct. You don't have to. In this case, the system stabilizes itself. You see, because when velocity increases, it reaches a constant value of velocity, which makes the RPM also constant. So there is no need an if condition in this case.
Tapi untuk our project,
You have to see first whether it has to be limited or not. Yep.
Berjalan nih.
Yep.
Oh, makin turun sih, harusnya naik. Dan juga torque. Velocity. Velocity dan torque sih fast time. Oh.
Kok malah turun ya?
Increase the time span.
Ini lagi kenapa torque-nya?
Increase the time span. Yeah. Try the 10,000.
Oh, error.
Okay, I think the time is up already. Yeah. What time is it? Yeah, like that. That's correct.
Oke. Ngestaknya di if torque lebih dari 6000 FTFT.
Remove the if condition lah right now.
Ini.
No need to get the if. Is it running?
Ini tadi.
Nilai kali saja.
Oh,
Huh? Yeah, you have hope. You see that? Is it working?
Jadi yang itu kan 6000.
This one?
Change di
Loading aja. Tuh.
tapi malah turun.
That's weird. Velocity versus time. Are you plotting time versus velocity or velocity versus time?
Time versus
You label it as velocity, but is it actually the time in here?
Balik ya.
time anjir ini.
Wait. This is plot t, x dot.
Velocity X tuh kan?
Yeah, the velocity is decreasing.
Yeah.
After that it stops. Oh no.
Balik.
X dot itu velocity-nya kan?
Velocity, it has to go up actually.
Jadi X.
Maybe your
Mati harus.
Itu kan betul kan time atas velocity.
torque is too small. Probably it is too small. Gear ratio is too
Bilisnya
small.
sih satu.
Yeah, that's to
Bikin dua gitu biar apa?
make it 4. Make 4.
torque-nya makin kurus.
Yeah, the graph increases and then after that it's flat. But where's the plot? Huh? What plot is that?
Mati X dot.
The TX dot should go flat. Look at that. Why this already very R16 not 16 lah. What 16 meter? Cannot 16 meter. You mean 0. Make it 0.2. 16 means 16 meter, you know, in that case. Yeah, okay. This one makes sense.
Dan X dot also berarti.
Yeah, that's next.
Velocity.
Okay. So you see, when your constant is wrong, not wrong. I mean, it's out of the boundary. Then the result is also not do what expect.
Gua bisa belajar.
Have you seen a car with tire 16 meter in radius? What is the radius of airplane's tire? Is it 16 meter?
I think it's even one.
Airplane.
2 meter apa lebih berat?
Lebih gede lagi.
It's bigger than 2 meters.
Masa sih?
No, just now, Madeline simulate the car with 16 meter of the radius.
Wow.
So that's yeah, which is why the result is not what we expect. So be careful with the constant, okay? Okay, I remind you again on the project. The deadline will be 1 December midnight. Yeah, you can still contact me at IT Lab if you have a problem with the simulation. Also, next Thursday, you can consult with me on your project. Okay, see you again next week.